Welcome, everybody. We're going to be working on the solution for the Module 4 assignment, which is the Hobby Manager. And in this assignment, you're supposed to pick an interest of your choice and create an application to manage items of your interest. So we're thinking about tangible physical items. For example, I might do guitars or cars or something like that. I am going to be doing candles, though, because I already have an application built, so I'm not going to do one from scratch. So I have all the verbiage already worked out. In this assignment, we're going to be using functions, conditional statements. We're going to practice loops, and we're also going to use classes, and we're also going to use our helper file. And we also have to add something to our helper file. And I believe that, it's listed as extra credit. But what I'm going to do is I'm going to start with that piece. So hint, 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 right? So if you've already turned it in and haven't done this piece and then add this piece, you could earn some extra credit. So like if you've lost any points on an assignment, this is a way to kind of boost your score a little bit. All right, so what I'm going to do is I'm going to start with this piece. I'm going to focus on my helper file first and adding that function as described. So over in Visual Studio Code, I've already attached to my Module 4 assignment folder, which is empty. And then my file system, I'm going to go hunt down my helper file from last week. That should be in the Module 4 labs. There it is. I'm just going to do a Control-C to copy, come back up and paste it into the assignment folder. All right, and then you see it appears here in the IDE, so I'm just going to load that up. All right, so going back to the instructions very quickly, it says include a helper py file, done. Add a function, get int in range, and we'll, like the other function that we have, we'll send in a prompt, and then we'll set a bottom and a top number. And this, it says this should inclusively get an integer from the bottom to the top number. So we're setting a range. And then basically, this is our way of ensuring that a number that comes in fits within the number range that we want. And then it will, basically either accept it and treat it like an integer or turn it into an integer or reject it with a message and ask the person to try again. And if you're not picking up on this, like the other function in the helper file, we're going to have a try except statement. So we'll have code that we're going to try and hopefully works, but it's possible, right, that either users try to break the system or they're fat fingering it or whatever and mistype and type words instead of numbers, right, which you can't convert to integers. And you don't want your program to crash when that happens. This is why we're doing it. So this becomes kind of like a good standard practice, actually, when you're doing a console app like this. All right, so I'm going to come back over here, and what I'm going to do is I'm going to build a new function. So I'm going to go down a couple lines and do a new definition. And what we're going to do is def get int in range, right? And we were told to have a bottom, a top, and a prompt. And I think the prompt came first. And then they called it bottom and top. What I called it last time was min and max. That just made more sense to me. So I'm just going to stick with that. It doesn't really matter what you call it as long as you understand. One's the lower number, one's the higher number. Like the function that we have above, I'm just going to force it to run. I'm just going to say while true, same approach. And then I'm going to set up a try statement. It always says that Boolean thing. I'm going to put in pass for right now, and then I'm going to put in except. So when there's an exception that happens, we'll deal with it here. All right. So let's think about what the exception might be. This is kind of a weird way to start. So like the error state. And think about it. One thing that they might do is if they type in a number, right, we can handle in the try section telling them, hey, it's got to be between like 1 and 4. So don't type like 10,000 or 3.5, right? But that we can handle with just an if statement. But if they type in words, I want to give them a message that's pretty clear. And I'm just going to say, please enter a whole number, right? Keeping in mind that most human beings don't know what an integer is, right? Unless they're actively taking a math class and they take the math class and then they forget about it later. And then you say, hey, type an integer. What's an integer, right? True, totally true. Like programmers know, but nobody else does. All right, so there's the exception. All right. Now, like we did above, we have to have a prompt, so it's kind of helpful to look at this. Could I just use the same prompt? Yeah, totally. And why not, right? So keeping in mind, this is going to be text that's coded into the main program that's calling the helper file. So whatever you want the prompt to say is going to be sent in, put on the screen, grab the input, turn it into an integer, and store it in user num, right? Same approach. Now we're going to check, very simple check. We're just going to say if the user num is less than or equal to the maximum number, and so a compound statement here, the user num is greater than or equal to the minimum number. Could I reverse the order of these? Yeah, totally. It doesn't matter, right? What order they go in. If it makes more sense to your brain to flip them, because I think it does for a lot of people, right? To like they start with the minimum number, go to the. I'm just showing you it doesn't matter what order they're in, as long as it's basically saying the same thing. And if the number is within range, then we just return the user num back to the main program, and the program keeps running. It, matches up with the menu choice, and off they go. But what if they put in a number that's not in range? Well, here's where our error message comes in. This is what I put in last time. So please enter a number between. So we're just reinforcing. And that's the whole function, folks. That's the only difference. Notice it's very similar to the original one. It's just making sure it's in range. It's not a very complicated one to write, but it's a little bit more helpful because, the top one will work for any integer, but it doesn't tell them, hey, your choices are between this number and that number. You can't go typing like 1 billion, that thing. All right, so I'm just going to do Control S to save. This is just a collection of functions here, right? And we're going to import this into the program that we're doing. Okay, so what I'm going to do next now is I'm going to go ahead and create my new assignment here. And I guess, instead of calling it like module 4 assignment, I'm actually going to call it hobby manager. So yeah, I'm putting a dot in there. Sorry. Hobby manager dot py is what I'm going to call it. Yeah, I'm putting capital letters in there. That's okay. It'll still work. All right. Now, first thing we're going to do in the program now is import the helper file. So I'm going to say from, of course, I'm typing on the wrong screen. From helper import. Which one are we going to import? I'm not really sure. So we can just import all of them. Right, that's an approach, right? It's like I can import all the functions. If later on I decide, hey, I'm only using one particular function, I can go back up there, change the asterisk to the particular function name that I'm using, and move on, right? But the one reason why you might not want to do the asterisk approach is what if there's 100 functions in there? Well, that all travels in with your code. It all loads up into memory. So you don't want to load stuff up that you're not going to use. So that would be something to consider. Right now, we have 2 functions, like 10 lines of code, not a big deal. Okay. So we're going to bring the whole thing in and then adjust from there. Now, I'm going to build a candle class. And if I remember from the instructions, we're supposed to have a few different data fields for a candle. So I'm just calling it class candle. And yes, I'm putting the class file or the class definition in with the running program here, just to kind of save space and time. I'm going to create an init function, remember double underscore init, double underscore. I always have to have the self-referring in there. And then I'm thinking about the the three different data properties I'm going to create. And of course, you can create more data properties than just three, right? But I think three was the minimum. And I'm going to do the scent of the candle, the hours or the length of time the candle can burn, and the stockpile. That's what I called it last time for some reason, which I think is how many of those candles do I have? All right. And then I'm going to take all of those and assign them to the internal data field. So these will get stored into the self version of the same name. So I'm going to say self dot scent equals scent, self dot hours equals hours, and self dot stockpile equals stockpile. I think I mentioned this last time, but when I'm teaching this at the other institution, when I teach this, I usually, because the book suggests it real strongly, and we have a book for that class, that when you do internal data properties, that you preface it with an underscore so that when you're looking at it in your code, you can instantly spot it. We're not doing that approach, but that is a technique that some people use. Kind of the same way, like if you have in Python something you assume is a constant, you name it all uppercase. Not that it really changes anything, but it's just easier to spot that you're treating it as a constant. So that's an approach that people do. They put an underscore in front of it. They know it's an internal data property. All right. So that's our init. And technically our constructor function or method. We're also going to build a string function. So like what's going to output if we're asking the class or object that's built from the class to print. So we'll do that by doing this. So we say def double underscore string double underscore parens. We have to include the self in here. Do we need to pass in parameters to print the data properties? Nope. All right, we just need the self-referring. Nothing needs to be sent in. And so then we just have to have a well put together return statement. I just happen to have one queued up over here. And this is what I did. So I made it an F string so I could drop the variables with curly brackets directly in there. But I said sent, hours, how many. Very simple, straight ahead. Shows me what the data properties are. It all prints on one line, right? And that just has to drop into a print statement back in the program. Right, so there we go. One of the other directives was that we should build a list of candle objects, right? This is something where I could like prompt the user to build the list, for example, but we want to pre-populate it. And so I'm going to create a list called candles, and notice lowercase c, s at the end, right? Because this defines one singular candle. See like the thinking behind like the naming here, where the list will contain a list of candles, plural, so it makes sense with the S. And this is one of those like weird naming things. You don't have to follow that approach, by the way, but it's kind of not a bad one. Jake.
Is there a reason you're doing? I don't. Maybe I missed it. Why you're doing a single instead of doing a double quote or the quote marks, you're just doing the apostrophe?
Because that's what I did last time, probably because somebody asked the question just like you're asking right now. So I'm like, oh,
Okay.
it doesn't matter. I can make it a double quote if you prefer.
I don't know if that made a difference. That's why I asked.
You know, the general rule in programming is like the reason they allow you to do either single or double quotes is because that way, if I wanted to put single quotes on something inside the double quotes, I could do it.
Okay.
And they would print. And then you still want to encapsulate them. So you use whatever one you're not using inside there to hold the whole thing.
Okay. Makes sense.
Yeah, but you know what? Good question. Absolutely. All right, so now I'm going to define my list of candles, and that we do that with square brackets. And I like to do the approach where I split them like that. And then I'm just going to pre-populate this list here that I've already created. And so for you, if you did something like, let's say you did cars or you did guitars or, you know, whatever your cats, right? If you're collecting cats, you could write their properties here. But I have 3 candles, a warm apple pie, an alpine forest, and an autumn harvest, right? These are the hours that they burn, and this is how many I have on hand. Notice this is basically a call to the class structure. So it finds the init, it sends in the 3 details, and it builds the object. Then that object is added to the list. Right, the first object's in position 0. This is position 1. This is position 2. Right? And if it's helpful for you, right, you could just put in a comment. You could say list position 0, right, etc. And you could just type that in. If that helps you to remember. And the reason I'm kind of bringing this up is today we're going to start talking about a different type of data structure called a dictionary, which is not indexed with numbers, right? So you can call it list position or index, right? And that's the more common reference. So index 0, index 1, index 2. And if we add more objects or append objects to the list, they'll get added to the end of the list. So the next one would go to position 3, etc. The highest position number, of course, is 1 less than the total size of the data structure. So this list contains 3 items. The highest index number is 2. Right? Why? Because we start counting at 0. Why? Because that's what computers do. Right? Computers get it. We don't. Right? Because it doesn't make sense to teach a kid to count on their fingers and toes. It goes, okay, kids, this is 0. That's not what you're taught. That's why we have to retrain our brains when we become programmers. It does become automatic after a while, by the way. All right. So like we did with our other programs, I'm going to build a big while loop at the bottom that's going to run the whole thing. So let's just go ahead and build that. We'll put our menu down in there. So I'm going to say while true, just forcing it to run. And then I have this menu that I built. See this one tabbed in, but basically we're going to add a candle, remove a candle, update a candle, and exit. So we're going to have basically all the CRUD operations are going to be present. The only one that's not available directly on the menu, by the way, is the list one, right? So if you remember the whole, CRUD thing, right, equals create, retrieve, which is usually our list function, create, retrieve, update, and we usually call it delete these days, but in the old days we actually would call it destroy, right? And I think that's a much more fun verb, as long as you're not serious about destroying things, right? But we're just destroying data, but let's call it delete, right? But that's what we call the CRUD operations. Now, obviously add a candle is create, remove is delete, update is update, and then retrieve is list, but that's not on the menu. But you can imagine that if you're going to remove a candle, you're going to want to list them first. And if you want to update a candle, you're going to want to list them first also. And in fact, even when you add a candle, you might want to list them. So we're just going to list every time. That's basically what we're going to do, right? Could you add a feature on the menu to list? Sure, why not? It's just another menu item, right? And in fact, maybe we'll just do that just for the heck of it. But we'll do that in the aftermath. This is our menu. As we've done in some of the other similar programs that we've built, right? So we've kind of established a pattern with this. We're going to now grab the user's choice. Now, we're not writing the prompt here and not converting to an int here because we want to use our helper function, our helper file, right? This one called get int in range, which we just built before, which is going to receive the text prompt, set the higher and lower bounds, and that it handles the user input and conversion for us and all the error messages and keeps the program running, even if somebody is trying to break it by typing in words or a floating point number. Okay, so that's kind of the why, right? So we're just using that function to do all that work rather than write all that code here or include that function Here, it's becoming part of our standard library of functions. Then we'll write our if statement to allow us to do some user selection here. So this is what I had last time, right? Notice these are underlined in yellow because I have not built them yet, right? That's okay. And the other thing that we've been doing, right, is we were adding an else to all this that basically would say, hey, that's not a valid choice, but let's talk about this here for a second. Will that ever happen? Yeah, it's not going to ever happen because this external function is kind of handling it for us, especially with the range function in place, right? Because now it's going to say, hey, you got to enter a number between whatever. So I don't need that else at the bottom. All right, so we're all set up to succeed. Question for all of you: does an else, does an if else if structure like the one I have here require an else? The answer is no. It does not require an else. And an if statement doesn't require an else. It can be standalone. Could I write this, right? So this is kind of like if I had like a midterm exam or a final for you. Could I write this with just a series of if statements instead of else ifs? Now you guys are a little more pensive on that one. The answer is you could. It would work just the same, right? Because that condition's only going to hit if the person hits that number, right? Yeah. So that would work too. I'm just kind of putting it out there. All right. So this is our big loop that keeps the program running, calls our helper file. Now we need to build all the functions that are underlined yellow there. So let's just do those one at a time. As I mentioned before, even though I don't have a menu option for it, we do want to list the candles, right? We want to have a way to be able to look at them if we're updating or deleting them at the very least. And then later on, we can add it to the grand menu. So let's just say, let's define list candles like so. And if we're listing them, we don't need to send anything in. We just need to get up on screen. And so what I did last time is I did a print statement. Make it look sort of nice, right? Blank line, little ASCII art, right? So you can see my list of candles. And then I set up an index counter, if you will, right? And presetting it to 0. And then I'm going to do a for loop. So I'm going to say for C in candles. So for every item in the candles list is what I'm saying here. And as I look at one item in the candles list, we will just call it C in the code. I will first increment my counter. And then I will print, and this one I'm just going to copy paste because it's so nicely done. I'm going to print the index number. So the first, it'll print 1, period, space, and then it will print the object, which will come up to the string method in the object and output this, basically, sent, hours, and how many. Once the loop is done, I want to put in a blank line. So I'm just going to do a print. And just to, drive home the fact that you can use single quotes, I'm going to put my escape sequence in single quotes. Now, here's another challenge question. Is this going to print 1 blank line or 2? What would happen if I just remove that? That will give you the answer. It will print a blank line, but I'm also having it print another blank line. So this is a way of like not doing the print statement twice. Here's kind of okay, this is a weird sideline, but did you guys know that in Python, I can do weird stuff like this? I can say hi, and then I can multiply it times 5, right? Like, what does that do? Well, that would print out hi 5 times. Isn't that cool? Right. Yeah, the weird Python features you never want to know about. We didn't talk about that, but I just think that's kind of a weird one. So that's just a addendum to the information. You can file it in the back of your brain and forget about it. All right, so that's our list function. All right. Now let's do the other things one at a time here. Let's go ahead and add a candle. So let's define add candle, spell it correctly. And then do I need to send anything in here? No, this is all going to be handled internally. So I'm just going to be putting messages on the screen to start. So we're just going to do a couple of text prompts. We've been hoping to receive text. What is the candles sent? Now notice, okay, so obviously this must have been a topic last year. We were talking about single and double quotes. Because notice what I did here. I encapsulated the whole thing in single quotes. And then in order to get the apostrophe S here, I did a backslash apostrophe so that that backslash would just work. Otherwise, the approach is make these on the outside double quotes, and then you can get rid of the backslash and the single will be fine. Sorry, that kind of, Jake, that kind of explains, you know, like your question. So yeah, you can kind of flip back and forth between the two. I clearly did that to make a point last year. And now I guess I'm making it again. All right. We're also going to say, ask how many hours does the candle last? And I might I might say how many hours, you know, whatever. We'll just assume it's hours. Yeah. And really, now I'm getting kind of weird about it, you know, because these are questions, right? So we should put question marks. Yeah, right. So it's like all my schooling is coming out now. It's like, oh, it's got to be proper English. Right. Here's my next prompt, right, for the stockpile. How many do you have? Question mark. Notice the continuation with single quotes. And then, as we did before on some of our lab exercises, we're going to use the append function for lists to add a new candle object. So we're using the candle constructor, sending all the information we just captured in these three prompts. Once the object is built, it's getting appended to the candles list. So this next candle will go in position 3, right, if we were to add one. And then when we're all done adding candles, let's create a list. List candles, so we can call our other function. I suppose I could list it to begin with and list it after. That's where I'm going to do it. You want to do it twice, go for it. All right, so that's add candle. Let's do remove. So here comes remove candle. Now I'm assuming like whatever hobby you guys chose, you're adding a car, removing a car, or whatever your thing is. Cats, right? Since that's the topic. Add a cat, delete a cat. Can't delete a cat though. All right. So we're going to start removing candles by basically listing the candles first. Right, so we want to see what's in there before we can remove it. And then, like we did in the previous examples during the labs, we'll do the same prompt. We'll just set a variable called index. We'll ask, which candle do you want to remove? -1. Now, okay, we could in principle, and this is kind of weird, we could use this one and do a complicated, you know what, we don't need to do that. I'm just going to use the basic get int. That works just fine, as we proved before. And then the approach that we used in the labs when we did a remove was to use the pop command. You guys remember that one? I talked about like the stack of dishes and the push and the pop and whatever. So the pop command is one that does remove stuff from the list, add a particular index number, and then we'll relist the candles to make sure it went away. So that's remove. Now we're going to proceed and update the candle. Once again, we're not sending anything in. We'll start with listing the candles. We'll do a prompt. Which candle do you want to update now? What? Once again, no question marks. For shame, for shame. Fixing it. Right. Yeah, good grammar counts in programming too. It really does. Then we're going to run kind of the same thing we did in, once again, in the labs is, oops, not a good copy paste there. Here's the command that I did. So look at how we're doing this. We're choosing the index number, and that's going to attach to the correct candle on the list, right? Because we're doing the -1. And then first we're going to say, how many candles do you have? So the only update that I built into mine, and you might have put in the capability for people to update everything, but I want you to think about this for a second. Is the name of the candle going to change? Right. So this might be different for you, right? Because if you, I don't know, if you're building, something different, have a different hobby where the name of the item might change. Well, great, yeah. Is the candle also going to change how many hours it burns? No. You see the logic? The only thing that I can really change is how many do I have? I bought more, or I use some. Those are my choices. So the only piece of information in any candle object I'm changing is the stockpile, is the number that I have. Once again, I'll put a question mark here. If it makes sense, for whatever your hobby is, to change some other aspect of it because it is changeable, then do it, right? If you can change all the data properties because it makes sense to you do it. I think logically here it does not. So once again, I'm going to relist the candles. And then that's all my code, right? So I'm done copy pasting all my code. So let's just kind of take a quick look from the top down. So our class definition, right? Helper import at the top. Our starting list of candles, candle objects, our list function and add candle function. Then our remove candle and update candle functions, and then finally the big while loop that runs the whole thing. Let's run it like this, and then we can go back and we can add the capability to list from the menu too. Greg, you had your hand up for a second there.
Yeah, just with mine, I was going to be able to update all three items. And what I ended up having, I kludged it together by just doing, do you want to go change the title? Do you want to change the author? And they kind of did, three particular checks. So you'd have to go through and change each time. Is there a slicker, I was trying to find a slicker way to do that, so I'd be able to do that and have them choose which of the three variables they'd want to change.
Well,
And didn't know if there was a better way to do that.
Well, one approach you could use is you could mimic the big while loop that runs the program internal to the update function, where it puts up its own while loop with its own menu, asking, basically, which feature do you want to update?
Okay, all right.
Right? Because it would use like basically, you could use the exact same code. You just change the verbiage on it, and change, instead of having a function call here, you would just have the script that changes it.
Okay, cool.
Yeah.
Thank you.
That's totally a thing, right? So, once again, this is kind of an experience thing, but it's pretty easy to spot this one, right? And I think if you thought about it long enough, you would think about that. And yeah, you could write other functions that handle those tasks, but if it's one line of code, you don't really need it. Right. Let's run this and see how it works. So here comes the run. All right. And let's go ahead and add a candle. Oh, of course, and I typed in the wrong spot here. Here we go. Adding a candle, right? What's the candle scent? Oh gosh. How about evergreen? 3 hours. How many do you have? I have 2. Okay. So now we see it on the list. All right. What if I want to remove a candle? Which candle do you want to remove? I'm going to choose 1. Warm apple pie does not sound good to me, and it lasts forever. All right. So then we can see it removed from the list. Now I want to do an update. So I'm going to choose option 3. Okay. which one do I want to update? How about number 2? How many do you have? I'm going to say I have 3 now. And I see the number changed. Now I'm going to try to put in a number that doesn't make sense. Now I'm going to put in a decimal. Now I'm going to put in some words. And now I'm going to put in something that makes sense, which is exit. And we can see all the options work. To add in the list, you know, very simple, right? We could just basically put in an Elif. And actually, you know, I would be tempted to put that first, but you know, it sounds like a lot of work, so I'm not going to. So let's just put that in as number 4. And just call list candles with parens, and then choice 5 will take us out. But then this option here, we got to change the upper range to 5. So that's adding that extra feature. And so now we have, save that. Oh, we didn't add it to the menu. Okay, that's kind of important too. Right, that's kind of useful. Probably should have copied number 4 instead of number 3. There we go. Save it, run it. All right, I never exited out here, so let's exit. Okay. So apparently my code was polluted. Let's try that one more time. All right, let me close the console. Now we'll run it. This is the real runtime with the added feature. There we go. The menu is expanded. And you know what? It could probably use a nice looking title, right? So, oh, you guys notice what else I did? I didn't update the menu choice here. All right, one more time. Here, I'm going to manually exit, and this should say list candles. It's all in the details, right? And you see what happens when you're really hasty. I just keep I'm like firing 100% here for sure. All right, so now I'm gonna type 55 to exit, right? Yeah, well, 5 is still my exit, but we can fix that. But I think we've already in principle proved that it works. And that last one, okay, you guys are gonna make me run it, aren't you? Let's just run option 4. So here I go again, running my code. And there's my list. And then we know all the other functions already work. Right? So folks, this is the solution for the module 4 assignment. I'm going to go ahead and save this one and close my console. And I'm going to stop the video from running. So this video ends here.